Hello and welcome to the YouTube channel D Creations Resources. We are looking at different concepts of mathematics under a particular playlist devoted to mathematics. And we are right now looking at complex analysis. Let us solve a couple of problems based on Taylor series. Now, power series is an important subtopic pertaining to complex analysis. And we know that if f of z is analytic at all points in a circle, say with a center at z0 and radius say r0, then at each point z inside this particular circle, we are able to write f of z as an infinite series. Or in other words, this infinite series converges to f of z. Now, of course, it is always helpful to know standard formulae pertaining to Taylor series. So, when you want to solve it, if you know the standard series, then you can simply do a little bit of algebra after writing the standard series. So, now there are three questions here. First one is 1 upon 1 minus z square. Mod z is to be less than 1. Now there is a standard series pertaining to 1 upon 1 minus z, which is basically summation as n goes from 0 to infinity of z raised to n. So now if we have 1 upon 1 minus z square, instead of z, you need to substitute z square, and that leads you to the answer n goes from 0 to infinity z raised to 2n. Also another question, that cos z minus 1 upon z square is the f of z given, and mod z lies between 0 and infinity. So again, there is standard series for cos z, which is 1 minus z square upon 2 factorial plus z raised to 4 upon 4 factorial minus z raised to 6 upon 6 factorial and so on, which basically you are able to also write it in the general form, that when n goes from 0 to infinity minus 1 raised to n, you can see here alternatively you have minus sign. And of course these numbers tell you that it's z raised to 2n upon 2n whole factorial. Now if it is cos z minus 1 upon z square, obviously you need to subtract 1 and then divide by z square, that's all. So after subtracting from 1 and dividing by 1 by z square, this is what you get. So last step you can write down where you cancel out z square, say, and minus 1 upon 2 factorial plus z square upon 4 factorial and so on. Similarly, if the question is f of z is equal to sine z upon z, where mod z lies between 0 and infinity, then again we can recall the standard series for sine z, which is z minus z cube by 3 factorial plus z raised to 5 by 5 factorial and so on, which again we can generalize it as summation going as n going from 0 to infinity of minus 1 raised to n z raised to 2n plus 1 upon 2n plus 1 factorial. Clearly you can make out that odd powers are involved here. So if you have to write it for sine z by z, you need to simply divide it by z. So everywhere, for example, in the first term, z and z will cancel out to give you 1. In the second term, z cube and divided by z will give you z square. So the term will become minus z square upon 3 factorial and so on. So it is always helpful to know the standard series for functions like, say, e raised to z, cos z, sin z, log function is also helpful. Or in the first case, as we saw, if you know it for say 1 upon 1 minus z, all these are going to be helpful for you to then solve for f of z, where little bit of modifications have been made to these standard functions.